Hello everyone and welcome back. In this third problem of general force system, we have to replace the loading on the frame by a force. So that's first thing, and the moment, that is the second thing, at point A. So for this what I'll do, I'll first redraw this entire frame. As you can see here, this is point A, then this is point B, and then a fixed point is given at point C. Okay, and what I have to do, I have to replace these forces, say F1, F2, F3, F4. Okay, this moment and moment produced by all the forces, all these things I have to replace by first force. So let me assume, I'm just assuming anywhere randomly, say this is that force R. Okay, and the moment, say moment I'm assuming in anti-clockwise direction, that I'm calling it as MA. So what I have to do, I have to replace these forces by a single force and a single moment without changing its effect, because basically what I have to find is a resultant. So resultant is a representation of number of forces by a single force without changing its effect. So in short, I'll say that these two force systems are producing same effect. Then let us start with the problem. So very first step is to resolve all the forces into x and y components. Now here you can see that all the forces are either horizontal or vertical. Starting from here, 300 Newton is a vertically downward, 200 Newton again downward, 400 Newton downward force, and 200 Newton acting towards left hand side. So here it's very clear that no need to resolve the forces that are inclined at particular angle to x or y axis, only those forces are needed to be resolved. Here while resolving, I'll assume that forces that are acting on left hand side are negative, so right hand side forces are positive. Upward forces are positive and downward forces are negative. So you have to remember that graph, plus axis, minus axis, then plus y and minus y. Okay, so we are done with step number 1. There is nothing to do here. Then we'll go for step number 2 and to calculate the summation of all the forces acting along x-axis. So we call it as Rx, which is equal to summation of Fx. So these three are forces that are acting along y-axis. There is only one force that is acting along x-axis, that is 200 Newton in left hand side. So here I have written minus 200 Newton because here I will say that forces that are acting on the right hand side are positive. That's what assumptions I have made here, that will remain same throughout the sum. Hence I am getting answer as minus 200 Newton, where minus sign indicates that 200 Newton of force acting on the left hand side. So here I have got Rx, that is summation of all the component acting along y-axis. Similarly, in step number 3, I will go for summation of all the components acting along y-axis. While doing this, I will assume that forces that are acting upward are positive, so downward forces will be negative. So Ry is equal to summation of Fy. Starting from here, first you can see is 300 Newton of force in downward direction, so minus 300 Newton, again minus 200 and minus 400, because 200 and 400, this both the forces are acting in downward direction. By adding this, I'll get answer as minus 900. That indicates that 900 Newton of force acting in downward direction. So here I've got answer of summation of Fx and summation of Fy. Now we will go for step number 4. So here we'll find magnitude of the resultant force at point A. So now I'll find value of this R. Okay, so what is R? Formula for R is under root of Rx square plus Ry square. To this I can also say that under root of summation of Fx square plus summation of Fy square. When I'll put this value, that is 200 ka square plus 900 ka square, then it will give me answer as 921.95 Newton, which is given over here. So I have got value of resultant R. Now I have to fix its direction. Okay, this is a general force system. You can see that none of the forces are meeting at a single point, or none of the forces are, these three forces are parallel to each other, but then this one force is perpendicular. So this force system is neither parallel nor concurrent, hence this is a general force system, and in general force system we have to find angle theta. What is formula for angle theta? So it's Ry upon tan inverse of Ry upon Rx. So by solving this, again we have value of Ry and Rx, that is summation of Fy and summation of Fx as 900 Newton upon 200 Newton. Remember that here we are finding the value with relative x-axis, hence we will always take positive sign. Ry and Rx, whatever respective sign I am getting, I will not consider that, I will consider only positive value, and hence here I will get answer as 77.47. Now let us plot resultant. So here this, you can see that this is positive x-axis and this is positive y-axis. Now here I am getting answer of 200 Newton in left hand side. So can I say this 200 Newton of force, this is giving me summation of Fx. Same way you can see Fy you are getting in downward direction, so this I am getting summation of Fy. Okay, so in between this I'll get resultant somewhere over here. This indicates Fy is negative and Fx is negative, that indicates that resultant lies in the third quadrant, and it's making angle theta with respect to x-axis. So that theta is how much? 77.47 degree. Okay, so now I have got this r ka value and then this theta. So I have got this r, I have got this theta, and then finally I have to replace it by what? One force and one couple. Okay, so let us go for a couple or a moment. So remember that if the force system is to be replaced by a force or a couple or a moment, then you have to take moment about that particular point. Here what they are saying, you have to replace the force system by a force and a moment at point A, and hence I'll take, in step number 6, I'll take moment about point A. What I'll do, I'll take moment about point A. Now all of you, it's very important. So let us start from here. When I'm taking moment about point A, very first thing is this 300 Newton of force will produce zero moment because it is passing through point A. What is formula for moment? Moment is force into perpendicular distance. When the given force is passing through the point A, then its distance is 0, and anything into 0. So in this case 300 into 0 will give you answer as 0. So we will ignore that force. Next is what? 600 Newton meter, that is moment. This moment is in which direction? It is in anti-clockwise direction, that is given in the sum. So I have taken plus 600. Remember, while calculating this, forces that are producing moment in anti-clockwise direction are positive and clockwise is negative. Okay, so first I am done with this 600 Newton meter of moment. Next I'll go for this 200 Newton. Now you can see that this 200 Newton is acting in what? Downward direction. So first what I'll do, I'll write 200 Newton. Okay, now since the force is vertical, okay, I have to find horizontal distance between force and point A. So what I have to find? I have to find this distance, and that is given as 3 meter. So basically 200 into 3. So 200 into 3. Now this 200 into 3 will produce moment in which direction? So it will produce moment in clockwise direction, and to clockwise I'll take it as what? Negative. So negative sign for clockwise moment. Third force is this 400 Newton of force. So first I'll write this 400. Now you can see this 400 Newton of force in downward direction. So what is the basic formula for moment? Force into perpendicular distance. Force is vertical, then distance will be what? Horizontal. So what is horizontal distance between 400 Newton and a point about which I am taking moment, that is point A. So A into this 400 Newton, distance between these 2 points is what? 7 meters. Then I'll write 400 into 7, and again this is producing moment in clockwise direction. So I have taken it as positive. I have taken it as negative. So here I have taken it as negative sign. And the last is, you can see here 200 Newton of force, and that is a horizontal force. So first I will write 200. Now when force is horizontal, so we have to find vertical distance between this 200 Newton of force and point A. Remember, it's what? Force into perpendicular distance. तो जब फोर्स वर्टिकल था मैंने हॉरिजॉन्टल डिस्टेंस निकाला, जब फोर्स हॉरिजॉन्टल है तो मैं क्या निकाल रहा हूं? वर्टिकल डिस्टेंस. यू कैन सी दिस वर्टिकल डिस्टेंस इज व्हाट? 2 meters. Then here I'll write 200 into 2, and then last is what? It's moment. Then you can see that this is producing again what? Moment in clockwise direction, and clockwise, so I'll take it as negative. By solving this, I'm getting answer as minus 3200 Newton meter, means 3200 Newton meter in clockwise direction. So in this sum, what I have done? First, I have calculated resultant, okay, because I have to replace given force system by one force and one moment. And what is that force? That force is resultant R. So for R, I have to find summation of Fx, summation of Fy, and then I'll get R, then I'll get theta. And then finally, here in this sum, it is not asked to locate the resultant R. They are asking to replace it by one moment. So I have to just calculate moment about that particular point. So when they are asking to locate the resultant, you have to use Varignan's theorem. When they are asking to replace it by a moment, you have to just calculate this moment wala part. I hope you have understood this sum. Thank you.